Hey folks, welcome back to another video. Today we're looking at question 37, Sudoku solver. The way we'll be solving this problem is by using backtracking. So what exactly is backtracking? So backtracking is a way of placing values and checking if something works. If it doesn't work, you go back to the first step and try it with something new. Relatively simple concept itself. So let's jump into the problem and see how we can solve it, right? So first we have the board. The thing that we need to do first is just check if the board is valid or not. So you need to check if the board is equal to null. What are the other things that you can check? So board of, you need to check if the number of rows makes sense, if it is not equal to 9, or if the number of columns, if it is not equal to 9, you would just return early, because it doesn't really make sense for us to solve it because it's not a valid board. If not, you try actually solving it. You try solving the board. So let's write a new method for that. And the reason why we are writing a new method for it is because it needs to be called recursively. So that's the reason why we have a new method entirely for it. And then we take in board. Okay, awesome. So we have the skeleton for us to solve. So what's the first thing that we need to do, right? So we know that we have to go through all of the rows and all of the columns. So let's set that up first. Int I equals 0, I equals 9, increment I. So this will take care of the number of rows. And then we have the columns. Int j equals 0, j less than 9, increment j, right? So awesome. So we are going through the rows and the columns. And the next thing you need to check is that for the given cell that we're looking at, do we need to perform an operation on that? Which basically means if it is an empty cell, then we need to do something. So let's check, right? So if board of I of j equals to dot, as in it's an empty cell, and we need to do something about it, right? If we need to do something about it, how do we do it? We need to check which value we can place. And how do we do that? Using a for loop. So char c equals 1, you start with 1 and you go all the way to 9. And then you increment c. And what's the next part, right? So the next part is to figure out if placing those values, all of those values, whether they make sense or not. So how do we place those values? So we check if we create a new method. Let's call valid placement. And then you send the board. You try to send the row and the column. And then you add the character that you're actually trying to place. If it is valid, we'll do something. And how do we check whether a particular value is valid or not? So you have a Boolean value, and then like a return value, and then you have this method, and then the parameters, right? So you have char of board and int I, int j, and the character that you're trying to place. So what determines whether a particular value is valid or not, right? It's in the like it's been placed validly. You need to check all of these conditions. For that, you need to have a for loop that goes through 1 to 9. Actually, let's call this 0, and then you have column, so that you can just call this I, and you don't have to worry about messing up. So int I equals 0, I less than 9. No, sorry, int I equals 1. No, actually, it doesn't matter because you're not checking. Yeah, so int I equals 0, I less than 9, increment I. So first you check if board of row of I equals to C, you return false. So what exactly are you doing here? You're checking if for a given row, all of the columns in that row don't have a C value. So basically you're checking if it has a C value, that means it's not a valid placement, right? So you just return false as it. So this takes care of the first condition. So all the digits must occur exactly once in the row, right? So you do the same for columns as well. And then you have, so this would be I, and then you have the column. Okay, so this takes care of the first two conditions. You're checking for the given row, the value hasn't been placed in any of the columns. For a given column, none of the values have been placed in any of the rows. And the next thing you need to check is the given block itself, right? So to iterate through the given block, you need to figure out the first cell. And you need to go through the two rows below that, and then you need to go to two columns after that. So how do you figure out what how the beginning cell is calculated? You calculate the beginning cell using these values. So row block, let's call it, and then it should be so row divided by 3 multiplied by 3. We'll walk through examples so that it's easier to understand. It would be equal to call 3 multiplied by 3. Okay, awesome. Okay, so let's look at examples, right? So let's say we want to figure out, we're looking at the center block, right? So what are the values for this? So 0, 1, 2, 3, 4. So that's a column. And what about the row, right? So that is the fourth row. And what column is it? So 0, 1, 2, 3, 4. Okay, the fourth column, right? And you need to figure out what is the starting, starting cell for that particular block. So how does that work? So if you use these calculations, so 4 divided by 3, which is 1 multiplied by 3 will give you 3, and the same value here as well. So 3, 3, is that the correct value? It is. Since 0, 1, 2, 3, that gives you the correct row, 0, 1, 2, 3, correct column. So this gives you the right starting cell, and you just need to increase the rows and the columns from there. So that would be a board of row block of row block plus I divided by 3, and call block plus I and modulus 3. So this will give you the right rows and the right column values. Okay, and then you need to check whether this is equal to C or not. So basically, you're checking if this value appears in the cell in the given smaller grid or not. If not, you're good. This would return false if the value does exist. And after all of this, you still haven't returned false, as in it's a valid placement, then you return true. Awesome. So once you check if a given placement is true or not, you actually assign the value. So you say, hey, take this I and j values for rows and columns and assign C to it. Right? So once that is done, you call this recursively. So you'll say if solve is equal to with board, if it is correct, you would just return true. So basically, after all of these values have been run, as in if everything goes through okay, and it has gone through all of the rows and the rows and the columns, you just return true. So if with the current placement you can solve the rest of the board, you return true. If not, you would just assign the current cell to be a dot, which basically means given the current choice, which is C, the board cannot be solved. Therefore, let's start with either assign new values to that or just assign a dot and start backtracking it, right? So if this hasn't returned true by now, you want to break the cycle. You want to say return false, as in, hey, you know what, it's not possible. So restart the board, as in that value, not necessarily restarted, but the current value that has been assigned and you're checking that doesn't work and hold all the conditions. So you're returning false and you're backtracking yet again. So that actually solves your entire problem, And once this true, return true hits, you return the board and you've actually completed the problem. Awesome. So let's try compiling this and see if it's okay. All right, so this would be INJ. And let's try that again. Okay, so the first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is n to the power of n. Reason why is because n are the number of cells that need to be filled up, and 9 is like those are the number of values that you can actually try for that particular cell. So each cell can have values from 1 to 9, therefore n to the power of 9 would be your time complexity. And your space complexity would be O of n. And the reason why it is O of n is because we are creating basically like a copy of the board and like sending it and to solve it again and again to see if the current placement makes sense and the rest of the values can be fit into the given board. Awesome. So that's how you solve the problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely makes me more motivated to make more videos for you folks. So thanks so much. And I'll see you all on the next video. Peace.